Good question. Okay, so this is number 12, 5 to 7 review, and this talks about two triangles. So we have similar triangles, and just like you learned in grade 9, because I just did a question like this last period in grade 9 math, that there's two triangles that are embedded. One is embedded in the other. So here's a small triangle right here, and then the larger triangle is obviously on the outside, right? So we have two similar triangles, and the information that they've given us is this. When two triangles are similar, you can use a proportion of corresponding sides to determine an unknown dimension. We know this. Solve the rational equation to determine the value of x. So you don't even need this diagram really, you're just solving this proportion right here. But x plus 4 is this long side in the larger triangle, and 4 is the corresponding shorter side of the smaller triangle. And then x over here, okay, this x right here is corresponding to this 3 right here. So we have two x's, these are the same length obviously. And so we're going to go ahead and try and solve this. And the tricky part is, different than grade 9, is that you have x's in two different spots. Okay? Should not be a problem, but let's go ahead and solve this. First thing you probably want to do is get rid of the denominators, so you can just deal with straight polynomial terms. So we're going to multiply everything by 12 here. And that's going to get rid of the 4 and the 3 in the denominator. So I'm going to have, for the first one, I'll just write it out fully for you. And on the second one, I'm going to have this. So if you take a look at each of these, 12 over 4, that reduces to 3 over 1. And 12 over 3 reduces to 4 over 1. So this is going to end up now to be 3 times x plus 4. Or when you distribute that, it's 3x plus 12. This one's going to end up to be just 4x. So now we have a very simple equation to solve. We're going to gather like terms, and this shouldn't be a problem. So I'm going to subtract 3x from both sides. That's going to give me positive 1x over here equals 12. So it looks like 12 would be our solution. And of course you could check that by putting 12 in for x here and see if that works. So 12 plus 4 is 16 over 4 is 4, and 12 divided by 3 is also 4. So it seems to check out. Good? All right. Any other questions about that one? Okay, so this is cumulative review 1, 2, and this is number 17. So in RST, triangle RST, RT is 2 meters, ST is 1.4 meters, and angle R is 30. Okay, so RT, let's go RT is 2. ST is 1.4. So here's S over here, 1.4. And angle R is 30. So this is 30 degrees here.
Would it be the other side is 1.4?
Well, I mean, depends how you, ST, not SR. Yeah, thank you. Yeah, thank you. 1.4 is over here. You're right, you're right. Okay, so determine the measure of the obtuse angle S to the nearest tenth of a degree. So, okay, so yeah, that way I'd have to redraw my triangle then. Let's draw this a little bit carefully. So 30 degrees would be a little bit lower. And if this is 2, and this other side is 1.4, then it's going to be about like that. So there is going to be, this angle is going to be greater than 90 then. Okay, good. And then RST then. Okay, so that's a better drawing. Okay, perfect. So determine the measure of the obtuse angle S. So you look at this and you say to yourself, well, can I use sine law or cos law, because I can't guarantee that it's a 90 degree angle here. It's obtuse. This one is probably not 90 degree. It can't be, I guess, but so sine law, I think we can use sine law. Not sure who asked about this one again. Who asked about this? Favor? So sine law, we do have an angle and opposite side pair, so that's great. Then I can use the sine law over here too for angle opposite side pair. So if I want the angle, let's put sine on top. So sine 30 over 1.4 equals sine of angle S over 2. So if I multiply both sides by 2, let's see here, I should get, now this is going to have, your calculator should be in degrees, make sure it's in degrees. Oh, mine's in radians. So let's go back there. So 2 sine 30 divided by 1.4 is 0.71428. 7 or so, equals sine s. And now for this one, just do second function sine to solve, to get s by itself. So sine to the negative 1 of both sides. Second function sine, and then if you have an answer function, which most calculators should, it's just an easy way to put the full decimal in. So it looks like 45.6 degrees. 45.6 degrees, and one decimal place I usually like more decimal places than not, so textbook might round to the nearest degree, which is fine. You can go to one decimal place for a degree, I think is good too. So that should be angle S. Angle S is 45.6. Does that check out with, does that look right? Oh, yeah, right. Sorry, we're not done. This is the obtuse angle. Wait a minute. Determine the obtuse angle S. Obtuse? Oh, okay. I thought T was obtuse. Darn it. Okay, that's fine. So S, I drew this incorrectly, thinking that it was T we're talking about here is obtuse. But check this out. This is part of the ambiguous case. Remember this? So all of this can still be true if we draw a triangle like this, where this is 2, this is 1.4, then this is obtuse S. Okay, so that's fine. We don't have to start over. Let me show you. So ambiguous case, we could have 2 different triangles showing up. And so we actually are focused on this triangle. Good, I missed that, the obtuse S. I assumed obtuse T. So this right here gives you the reference angle. So that's always, your calculator is always going to spit out an acute angle. When you do the second function of a trig function, it's always going to give you an acute angle. And that just means that it's either the real angle or it's a reference angle for the real angle. Knowing that S is obtuse, this means that really this is 45 degrees right here. This is 45.6 degrees, this angle. So it's the supplementary angle to this that we're looking for. So angle, that's going to be angle, okay. So that's going to be the reference angle. There we go, reference angle for angle S. And so angle S then, because it's obtuse, is going to be 180 minus 45.6 degrees. So what's that? 134.4? 134.4? How's that? That's right now, right? Okay, good. Yeah, so ambiguous case, you could draw a triangle 2 different ways. The Q's in the question here is what we missed here. Obtuse, angle S. Yeah. All right, good. Yeah, a few details there. Gotta keep track of. Okay, anybody else? Question? About any other number? Okay, I'll let you guys continue studying and working for your final. Please make sure you have your cue sheets ready, and these review assignments are handed in before the end of the day.